Welcome to On Block Off Block by AeroCloud. On Block Off Block explores the exciting and ever-growing aviation industry with guests working in and with airports, and is hosted by AeroCloud CEO George Richardson.
In this episode, George speaks to Paolino De Falco, project leader and data scientist at EUROCONTROL, about his journey into the aviation industry and the integration of AI and machine learning in air traffic management, the need for collaboration in the sector, and insights on the skills needed for a career in AI and aviation.
Paolino, welcome to On Block Off Block by AeroCloud. Thank you so much. I've been really looking forward to this one. You are at the forefront of AI and machine learning of our industry, and I'm super excited to speak with you. Thank you very much for joining.
Thank you for the invitation and for the very nice introduction. It's really my pleasure.
Fantastic. Good. Let's get straight into it. Why aviation? Yeah. What was the moment that you realized this would become your vocation? Because I can imagine you're a very, very busy man. What made you decide to pick our industry?
Yes, that's a very interesting question. Indeed, the answer is a bit complex, I have to say, because, of course, I made my first choice. So I felt my first vocation when I decided to study aerospace engineering. However, after finishing my bachelor and my master degrees in aerospace engineering, I felt that I wanted to keep studying and keep exploring new subjects, new topics. And that's when I moved to London for a PhD in mechanical engineering. And I started my career as a researcher, mainly focusing on material science, biological materials. I moved afterwards to Germany, and it was maybe during my period in Germany that I felt this second vocation for aviation, simply because I was feeling nostalgic when seeing an aircraft or when being at an airport. And I thought, although I was very happy of the kind of career I started and of the kind of research I was doing, I felt I had to give a second chance to aviation. And that's when I moved back to London to start working at the University of Westminster in air traffic management.
Fantastic.
So, yes.
And AI is relatively sensitive in our industry. I think people meet it first with scary connotations. AI in ATM specifically, probably very scary as well, given that your organization was responsible for an awful lot of data, providing that data to most stakeholders, I would say, if not all stakeholders. What have been the main challenges that you've had in your department that you've come up against on educating our industry about AI and its adoption?
Yeah. It's a very good point. So I think there is a lot of good research and a lot of good work that has been done in the research community using AI and machine learning. However, I see that there is still a bit of skepticism when it comes to adopting these technologies. So, and indeed, I agree that there is a process of educating final users to explain how to use the tools and to explain how the outcome of an AI solution is derived. So, I believe this is a process which requires time and will require more and more effort. And maybe on this point, I could briefly mention the experience with Prague Airport. I've been working on one of the projects called OPTT 1.0, so Optimized Turnaround Time Prediction, which focused on prediction of turnaround time duration and target of block time, which is one of the major milestone in CDM airports. Maybe we can explain quickly what is this TOBT. The target of block time is basically the time that either the aircraft operators or the ground handlers estimate that an aircraft will be ready for departure. And this estimation is done in advance, so before departure, a few hours before. And so the idea there was really to use machine learning to make this prediction and to help the humans making the best possible decisions. So at the end, we developed this model not only with Prague Airport, but also with few other European airports. And the model has been adopted by Prague Airport and deployed in the airport systems.
And
it's currently... Yes.
sorry to cut you off there. Just for our listeners, let's get real world now. Why is target off block time so important to stakeholders, and what stakeholders are affected by the wrong prediction of this, and what are the consequences? Let's talk about this in a real context, as taking examples from Prague for me.
Yes. So in principle, aircraft operators are responsible for the release of the target off block time, but they can delegate local ground handlers to the management of these values. These values are very important because imagine, for example, you don't have any other information. The target off block time can be an estimation of the stand occupancy time of an aircraft. So it can give an estimation of how long an aircraft will occupy the stand for. It is also used at specific stages in time for the calculation of the ATFM delay. So it's one of the input to calculate the slots. And so has a lot of impact on the network level, I would say. So as I said, mainly in Europe, ground handlers handle these values. And they have to do it in a very dynamic environment, super complex environment, typically also based on few information that is available at the airport or local, especially when these predictions needs to be done few hours before the actual departure. So when the aircraft maybe is not even at the airport yet. So in these cases, I think there is a lot of potential for machine learning to support the humans who have the actual responsibility of releasing the values.
And what are the knock-on effects to not having the data in the network? So EUROCONTROL are probably best placed for this in Europe, certainly, because you have that visibility. Do you have enough historical data, or do you still need some more? And what are the parameters in which this project may fail, if that makes sense?
Yes. So just to link to what you just said, I'm currently working on the 2.0 version of this project, so OPTT 2.0. In this project, I'm focusing on prediction of target of block time, but for all the CDM airports, which are 33 in Europe, with a unique machine learning model. So in this case, we see that we can predict very well the target of block time until, I would say, the beginning of the turnaround. And afterwards, as the model has not been trained with useful input to predict, for example, possible issues on the ground, passenger being late, and those are all factors who might trigger an update of the TOBT, because this is something we didn't mention, but the TOBT can be also updated by the stakeholders. And this is kind of data that is very difficult to incorporate in a machine learning model, because most of these occurrences are unexpected and by definition unpredictable. So for this specific topic, I think machine learning makes sense until beginning of turnaround. And afterwards, indeed, there is some new technology which is quite relevant, and it's computer vision. You might be aware of a lot of models and technologies based on computer visions that have been recently developed to monitor the aircraft on the stand, and also to predict the duration of all the ground, of the single ground operation. And so I think, yes.
Sorry, we're very familiar with that, and AeroCloud is developing those tools sort of post the prediction from what we've just discussed. But can we just delve into that? You said, there's a lot of people that need to be on the same page. So who are the stakeholders that need to be on the same page? And then latterly, who historically are the worst offenders in the reactive or unpredictable piece of the jigsaw? Is it fuel? Is it boarding? Is it waste extraction? Is it food delivery? Who are the worst offenders, and what stakeholders should be on the same page?
Yes. So it's a nice question, and maybe also a bit complex. But what I can say is that during my project, I've done some experiments. So I assume that first of all, I asked Austrian Airlines, which is one of the stakeholders in the project, to share with me some data about passengers, because one of the possibilities to postpone the target of block time is late connecting passenger, for example. Or late boarding, so delay during boarding, issues during the boarding. And therefore, I asked for this data set, which was able to describe the number of passenger, the type of passenger, the number of connecting passengers. So I included in this model all this information, as well as I also included all the possible types of ground delay according to the IATA delay codes, which define and describe this kind of delay. So I assume that a machine learning model would be informed about these delays as soon as they happen, right? Which is an ideal case, but I wanted to verify whether in this ideal case, this prediction could somehow improve. And what I observed for the prediction of the TOBT of Austrian Airlines operating at Vienna Airport is that they could improve by 10% with the inclusion of both passenger information and delay information. So there is a margin to improve this prediction. However, we also need to consider how complex will be for an operational model to incorporate also data about passenger and delays, so ground delays. And because of this, for me, this remains an experiment, while I'm mainly focusing on a model that can be deployed, because we have enough data and enough type of input, which still allow for very good prediction at the network level. And so I think that's my sort of answer. Then, of course, this prediction can be useful for the airports because they can have, again, this estimation of the stand occupancy time. They are useful to airlines, especially when they do not operate at their hubs airport. They have basically no visibility on their aircraft, on their TOBTs, and everything is delegated to the ground handlers. And we see a lot of potential support in that case. Ground handlers themselves might benefit from this prediction to better allocate the resources. In the context of CDM, the TOBT is also used for the TSAT, the target startup approval time, therefore for the pre-departure sequencing, so to decide which aircraft is going to depart first. So there are a lot of possible application, as well as the decision of the allocation of the pushback tracks, for example. So there are really a lot of possible application linked to the model usage.
Yeah, I think the unpredictable nature of the post-prediction that you're working on is something that we're very interested in, because we own the product that is checking in passengers and doing the departure control of passengers. Then there's some nuances within, does a passenger have any checked luggage? Where is that luggage? And has that luggage made its way onto the aircraft? What's the agreement that airlines have with passengers as about when they should have boarded to when they can take off without them? Then you've got a passenger in terminal, and then it becomes an airport operational issue. As per the IATA delay codes, and when I was researching this myself, I think there's about 60 different ones, I think, that happen in a full turnaround. Please correct me if I'm wrong. But I saw that things like fueling, boarding were the main offenders. Effectively, they accounted for over 60% of those delays. Is that correct, or am I on the right train of thought there?
Well, I'm not sure about this percentage, so I don't want to say incorrect numbers. But yeah, I think
a high percentage.
Yeah, I would
and that's
say
where computer vision can help. That's where computer vision can help, because then if you look at it like a Zurich, for example, which I believe you're working with as well, or Prague, there is a lot of visibility coming on to the ground handler. So my next question is, how have you found the ground handler's adoption when effectively the visibility of their operation against their SLA is now totally visible by the people that are paying them? So they have to be far more efficient. They have to be far more professional. They have to be far more visible, because in the past, maybe they would take a blended view across the day on their performance, and maybe it was a bit more subjective. So is this scenario alienating the ground handler a little bit on their performance? Because they have a lot of challenges, right? We have a large customer in Swissport. They're the largest ground handler in the world. And one of their biggest issues is post-COVID, people left to retrain as a chef, a school teacher, etc., etc. They didn't necessarily come back. And we all know that ground handling is a very, very tough job. It's not the easiest job at all. Long hours, adverse weather conditions, etc., etc. So how have the ground handlers engaged with this project, and how can we provide them some value back without alienating them? Because they're such a large part of this,
Yes,
it would be
absolutely.
unfair just to go both barrels for them
Yes.
when we need them, but at the same time, we want better predictions. So how have you handled that? And is there any stories that you could share or
Yeah,
any
of course.
comfort that
I
you could
have.
give ground handlers?
Yes. I'm going to share some stories that the colleagues from working at Prague Airport have shared with me. So basically, of course, the release of the TOBT remains a task of the ground handlers. So first of all, maybe we should quickly describe how the model has been implemented in Prague. And basically, the model automatically provides TOBT values to the ground handler, so the first estimation of this value. However, ground handlers can decide whether to take that value as a final TOBT or whether to update it if they see a need for this. And I think this is the right approach because we need to maintain, I think, in almost all the AI application in aviation, the human in the loop, especially when they are really responsible for the task. So this is the first point I wanted to highlight. The second point is that, of course, at the beginning, also at Prague Airport, they encounter some sort of skepticism by the ground handlers themselves because anyone will say, okay, that's my job. I know how to do it. I don't need anything to support me, right? That will be the natural reaction. However, during a busy period in summer, handlers were busy with multiple tasks simultaneously, and they were almost forced to rely on this supportive tool because they were busy and they could not really focus as they would in other occasions on the supervision of TOBTs and turnaround. And it was in that occasion, so the past summer, that they realized that about the quality of the model. So they realized that the predictions were actually good. And then progressively, they started gaining more and more trust. And currently, as far as I know, I don't want to say any incorrect number, but as far as I know, 65% of these predictions are accepted as a final TOBT release, and the remaining ones are updated because of ground issues or because the ground handlers express the needs of updating these values. And I think this is a very interesting process, which is what I expected. It would be very weird to see an AI tool fully accepted immediately in operation by people who run operation. And I think it's a good example. And this is maybe the example that we should follow for other applications. Personally, it's the example that I will bring forward for OPTT 2.0, so for the follow-up version of the project. Where I wish that more and more airports will follow the example of Prague, because from the results that I see, and currently we are testing the prototype with the live operational data, there is potential for almost all the CDM European airports to adopt the same approach as in Prague. Yes.
Well, you certainly have the network capability of deployment with working within. You're in the right organization for your field, right?
Yes. Of course, we will try to. The model can be centralized at EUROCONTROL, of course, but we are also open to hand over the model to the stakeholders themselves. For example, if they wish to integrate the model in their systems, we are open to hand over the model, as well as we are open to hand over the model to industrial stakeholders. So we are discussing with the industrial stakeholders, and whether they see the potential of integrating these models in their own system, we are happy to hand over. And maybe just a few words about this innovative initiative that we are running at EUROCONTROL, which is called ETIN, EUROCONTROL Air Transport Innovation Network. That's the acronym for. And it's indeed an innovative initiative giving the possibility to operational stakeholders to come up with new ideas for projects. There are pitching sessions that we handle twice a year typically. And at the end of this pitching session, we analyze all the proposals from the stakeholders. We select few of these projects, the most feasible and promising ones. And that's how we start this project, which are indeed very much target to the final handover deployment of our tools, of our models within a relatively quick time. So we are talking about 1, maximum 2 year period of time for the entire duration.
Sounds really exciting. So can we just go a little bit back to how you measure the success of what you're working on? You mentioned the 65% number, and we won't hold you to the number, but in the pre-tactical planning phase, what is the target? And how do you measure success? Is it by data points that are successfully correct post, or is it in a reduction of time from turnaround as a recorded number?
Yeah.
How do you measure success of the project?
So I've been working on a few projects where we were supposed to develop a model providing prediction in a pre-tactical planning phase. So the model was supposed to be used a few days before the day of operations. And when you deal with machine learning with this time horizon, that's how they are called, the main challenge is the availability of data that you will have in the at the inference time. So in the operational context, that then will actually where the model will be actually deployed. So when we talk about pre-tactical phase, the main challenge is that in machine learning models, you cannot include weather data, for example, because the forecast a few days before the day of operation, we know is not going to be very accurate. We don't know about ATFM delay, and so we cannot include it as an input for the model. We don't know whether there will be strikes, disruptions. So I think there is still potential to apply machine learning in the pre-tactical planning phase. However, we need to be aware that the results might not be fully satisfactory for specific tasks. And maybe an approach that should be or could be adopted is to use probabilistic approaches. As we are dealing with a very dynamic and complex environment, so air traffic management, plus we have the challenge of not being able to include all the possible data that we wish for, as we are working again in the pre-tactical planning phase. So I think we need to maybe try or develop probabilistic models, which instead of giving us the exact prediction of whatever we are going to predict, give us an estimation or a range of possible estimation within which that prediction will fall with a certain probability, right? So we could say you have 90% probability that your prediction will fall within these intervals. And I think there is potential to use even this kind of information in the pre-tactical planning phase. However, of course, as we said earlier, there is always this educational process. It's not easy to communicate to the final user the outcome of these models, but I see some potential.
Yeah, but that's where I think other stakeholders in the periphery will help that. And I wrote it down because I'm gonna butcher the way I pronounce this, but probabilistic effectively approach with giving a range. And that's why, well, my interest in speaking to you over time has been when this project develops into a real deployment across the EUROCONTROL network, the periphery stakeholders are also going to be engaged because, like we say, the reactive nature of speeding up that turnaround also has an impact. The efficiency of the operations communication, for example, is linked into getting that aircraft moving again. The connection between the ground handler and you guys and then also the airport is also of paramount importance. So when we talk about range, I think that's probably the only way we can do it, right?
Yes.
And again, when we go back to talking about blend and the example of the ground handler performance, if you've got a contract with a ground handler to do 1,000 turns a day at a large airport, you can't judge them on one turn. You have to judge them on the blended performance. And I think that's so interesting about this initiative. And that's my interest as to where this is going, because those operational partners, not necessarily true stakeholders, can also contribute to making the difference to benefit everybody. And that data should be mutually available. So will this data be mutually available? And where do you see the future of where this could go with that in mind?
Yeah, so I mean, as I said, there is a lot of work that we are doing in the research, and some of this work remains as such, so remains on the paper and is not really used. So I think we need to work more and more on the deployment and on the handover of these solutions. If we want this work to really be useful to improve the efficiency of air traffic management, we need to spend some time in this. So for me, this remains one of my main tasks as well, because I've done a transition from data science towards project management exactly for this, because I felt that there is this lack of adoption of our work, and so my commitment is really towards an increasing adoption of our models. And to do this, we need to talk to the stakeholders. We need to talk to the ground handlers. We need to talk to the airports, to the airlines. We need to understand their needs. We need to improve the way we communicate our work, because it's not always fully understandable by any profile. So we need to translate it into something that can be digested by anyone. Even the outcome of our models sometimes needs to be transformed into something meaningful to different stakeholders. So it's very difficult. It's very complex, but that's the fascinating part of working in this environment, in this sector. There are continuous challenges, but at the end, we also see that we are very close to the real world with our research, and this is not obvious. I think in the world, most of the research is not really applied, which is a pity. But in some cases, of course, it's also needed not to be applied. So in this case, having really the possibility to make an impact on the ATM is what is inspiring. And yes, so I think in that sense, there is a lot that still we can do.
Yeah, I find the same in my view, and building our business is lack of adoption of new technology has been a significant challenge. We've now had the adoption of AI in every industry. And
Yes.
on one hand, the stakeholders want AI. And on the other hand, they're very scared of the adoption of AI and what it could mean personally in their roles. And I find that what I would love to see is more people having these sorts of discussions about debunking the myths around that it could be dangerous, and actually show the people and the research papers that you've built and this massive amount of wealth of data that you have to show that the chances of getting it wrong are still there, but they are drastically mitigated.
Yeah.
Because there's some really clever people doing this right now. This is not some guys that are just having a go. This is some really clever people that have got some proper funding to do proper research with proper stakeholders, and then also allowing them. And one of the adoption methods that we've seen is let them run their old process at the same time as running the new one.
Yes.
So that they can show how it can overlap, and then also educate all users and all stakeholders around the table through things like open forums and open training sessions, something we do a lot at Aerocloud. We spend hours and hours and hours a week with the customers and customers' stakeholders to educate them on the benefit of the solution. On the flip side about our industry is once new technology has been adopted, there is a trust basis that builds. So in your case, the 5 or 6 airports that are currently using your research and models will tell 5 or 6 more next month and next month and next month, and there'll be a compounding adoption. And that's what I find amazing about this industry. I've built our business from 0 to 70 airports using our technology, and it's so much easier now to sell the technology because we have 70 airports already using it. So
yeah, you have the case studies to show, actually. Yeah,
100%. And anybody that's listening that wants to be involved is a benefit, as long as they are acting in mutual benefit, because this is really, really powerful stuff. So,
and you mentioned something very interesting, which is the fact that you spend time with the stakeholders to explain how the models work, how the tools, the technologies work, what are the benefits. And this is not obvious from your side, but neither from operational people who are typically very busy dealing with daily operations. So, but I think that's the key. As everything in life, if we want to make things well done, we need to spend time and dedicate the right amount of effort to each step of the development. So I think this is definitely something that maybe also I will take it as an example. I will try to do it more and more with the stakeholders I work with.
But I think that's always an age-old problem or challenge. I'm not technical at all. My co-founder co-founders were technical. And the reason why could be perceived as a successful business is because we have a mix of technical people that really understand the domain and commercial people that can get that technology into the industry. And I think that is something that maybe is often mislooked at the conferences, for example, is that you are busy doing research. Airport operators are busy operating their airport. And actually there needs to be a commercial gel.
Exactly. Absolutely.
And that's why vendors are very important in this space. And vendors should have a relationship with their stakeholders. It's one of trust. I always say to my airports, if you're ever thinking about doing anything with technology, please call me first, because I would love an opportunity to give my opinion, because I'm the type of person that will make it happen and push it through. And this maybe is not the skill set of the airport operator or the researcher. So That's what these projects are really good at. And that's where I think my interest of our conversations have been, is that how can we help with the adoption? We're a commercial enterprise. We need to make money. Operators need to satisfy their clients and also their passengers. And you need to make sure that this is adopted for the value of your chain, your network chain. So that there has to be a lot of talk around which stakeholders are around the table and how we all help each other.
Yes, absolutely. And indeed, the idea of eating, which is this innovative initiative that I mentioned earlier, is really to build this link between the industry and the stakeholders. And that's why we are open to hand over models to the industry if they are happy to take them, because our goal is really to help the operational people with something useful. And of course, initiatives like yours are very, very useful, very, very interesting. And I think there will be a growth of this kind of enterprise of companies, because there is a clear need, especially with the situation that in a way could be also considered critical for certain aspect. If we only think about the increasing demand of traffic in a saturated airspace. So this is clear that we need solutions that can be quickly deployed if we want to make ATM more efficient. So that's why it makes fully sense that you are in this environment contributing and supporting as you're doing.
Absolutely. Well, fascinating stuff. Let's move on to the sort of the last segment, is that, I haven't had any significant researchers on our podcast before. So what skills and knowledge areas would you recommend for those interested in pursuing a career at the intersection between AI and ATM, or aviation more broadly?
Yes. So, of course, I think there is an increasing need of people with expertise in modeling, which is not only AI. I think also there is a potential for a lot of optimization techniques that can be implemented to improve the decision making. Therefore, also, yes, mathematical background could be very, very useful for people who want to start a career in ATM. People who want to do data science in ATM, of course, they need to have maybe some more specific skills related to data science. So some knowledge of the main algorithms is always useful. Python as a programming language is what I would suggest is the mostly used in research. And I think overall, young people could bring their enthusiasm, their motivation, which is, of course, always needed in any industry. So those are maybe the few advice I feel I could give.
Absolutely. And in terms of what you would like to see change, what loses you sleep at night, is there any areas of focus that, if anybody listening out there is addressing now, that would perk your interest? Anything losing you sleep?
Well, thank God I still sleep very well, and I don't really lose my sleep. However, it's more or less what we discussed before. I would like to see more of the research applied in real life application. In this case, in ATM application. It's really what drives my daily work, and it's really my goal, I would say, in my current position, in my current role. So I see that there is all this potential, and it's what in the future I wish that more and more application will related to AI or to the modeling that we do will be deployed and used.
Fantastic. Well, you have an incredibly bright future ahead of you. I really look forward to the potential of working with you and the applied knowledge that this can give many stakeholders across our industry. Thank you so much for taking the time to speak with me and taking the time to dedicate a large proportion of your life to this problem. So thank you very much on, I'm sure, behalf of many.
Yeah.
If people wanted to get in touch with you, what would be the best way? And I will include all of your links to all your research papers, the PDFs of the probabilistic prediction papers that you've worked on, and also your LinkedIn. But what would be the best medium of people getting in touch with you?
I would say LinkedIn maybe. And if you share also my email address, that also can be useful to reach me out. So yeah, definitely these two ways will work. And thank you for the invitation, for giving me the possibility to have this nice discussion. So I really enjoyed it. And thank you also for your work, because as we said, your kind of initiatives are appreciated and needed in the ATM context as well.
Thank you very much. Yeah, I appreciate you. And I will see you at this year's PTE where you are speaking. I'll also put that detail in.
Thank you.
Thanks again. And we'll catch up soon in person, I hope.
Yes, definitely. Thank you again. Bye.
Cheers.
Thank you for listening to On Block, Off Block by AeroCloud. If you enjoyed this episode, please leave us a review and remember to hit the subscribe button to stay up to date with future episodes. On Block, Off Block is hosted by George Richardson and produced by Alex Greaves.